Hi, my name is Vince,
My name is Matthew.
My name's Jaewon.
and today we will be sharing our findings on the analysis of Spotify songs.
The first question is what audio features contribute the most to a track's popularity? Um, the graph shows that acoustic, danceability, and loudness are closely related to track popularity, while energy and instrumental are relatively unrelated.
Alright, our next question was what genres have the highest average danceability ratings? So as you can see in the visualization, most of the genres have around the same average danceability. The only one that has a big difference is rock. So with this visualization, we can try to identify how big of an impact danceability might have. And since we can see that the average danceability is very similar for all of them, it might not be that good of an indicator.
And for our third question, we wanted to explore whether there was a correlation between loudness and tempo. And the intuition behind this is that songs from energetic genres like EDM and rock are typically loud and high in BPM. These features are utilized to invoke certain physiological responses, and we just wanted to see if these might extend to other genres. And we discovered the answer to this question by using a regression plot. Since the data set was dense and widely spread, we removed outliers and created the visualizations with random samples to give a more focused view of the information. Next slide, please. And as you can see from the regression line, there's a weak positive relationship between loudness and tempo. And this was numerically confirmed with the correlation coefficient, which we found to be 0.09. And our general takeaway from this is that a correlation may exist for specific genres, but most other genres may be more experimental in their use of tempo and loudness to invoke different emotional responses.
Alright, our next question is do longer songs tend to be more popular? So we just mapped it into groups of song length, and as we can see in the graph, songs that are around a minute and a half to 4 minutes and a half long are much more popular. At least their average popularity is much higher than all the other song lengths. So with this visualization, we can kind of deduce that if a song falls within that range, that it has a much higher chance of being more popular. And as we can see, to answer the question, longer songs tend to be the least popular. We can see that the 7.5 minutes to 9 minutes one is the least popular of the bunch. So yeah, we can deduce that longer songs are the complete opposite of what we thought.
For our fifth question, we wanted to find out if artists with greater genre variety are more popular. And again, our intuition told us that artists who cover more genres are able to capture a wider listener base. But we just wanted to see if the data could also back this up. To do this, we used a violin plot with artists categorized by popularity and the number of genres each artist covered as variables. Next slide, please. Using the plot, we discovered that on average, artists labeled as very popular spanned 5 genres, popular 4, somewhat 3, and niche 2. And to answer the question, yes, very popular artists tend to cover more songs in their music, but in extreme cases are less experimental compared to somewhat popular and popular artists.
And we developed a machine learning model to classify songs into genres based on their audio features. First, model comparison. Uh, we used three models, logistic regression and random forest and XGBoost. First of all, we did pre-processing. We removed missing values and scaled features using standard scalars and encoded target genres with using label encoder. And for balancing the dataset, we used SMOT technique, and then we split the data 80% training and 20% testing. And this is the model result. We chose the best model as XGBoost, and then we did fine tuning as uh, estimator like 200 and max depth is like 6, kind of like and then learning rate is 0.1 and subsample is uh, 0.8. And finally, we achieved an accuracy of 55%, uh, 55.38%. And then XGBoost balanced precision and recall across genres. And then Random Forest provided insight into key features influencing predictions. And for challenges, uh, for genre 2 shows overlapping feature distributions and leading to lower classification performance.
Alright, as for additional issues and challenges we had, our initial ML goal was actually to predict popularity, not genre. But we were messing with it a bit, trying to get it to work, and we found that popularity had a very low correlation with the features. So we would always get a very low accuracy score with our ML model. So we decided to switch over to predicting the genre instead, since there was more correlation there. Another issue we had was trying to find the best hyperparameters for our ML model. So we use some things like grid search and randomized search to try to find the best combination, but it didn't really give any sort of accuracy score boost compared to what we already had. So we decided to not include it in our slides. That's all. Thank you for watching.
Thank you.